In this video, we want to discuss different ways in which we find research topics and write papers. Probably the best way to learn is to look at the path taken by someone like you. Let me start with a question. When you started your PhD, how did you pick your first research project?
Well, maybe the answer to that one is not so interesting as you would hope, but I think it's a typical path that many people take. The first project that I did at Berkeley was suggested by my advisor. It was a project on sensor networks that was quite interesting on routing in multi-hop wireless networks. And that project started with an internship and remained working on that topic on and off for the rest of my PhD.
Great. Seems like that was very easy, but that's not the only project you worked on during your PhD. So tell us about how you came across some other projects during your PhD.
I think finding new projects is one of the major skills that you end up having to learn at your PhD. The most common way that I found that I started new projects was from hooks that I found in previous projects. So I started working on that routing project in sensor networks, and I got a lot of experience in the inner workings of TinyOS. So I did a lot of projects related to that. I did a project on fast forwarding of packets on multi-hop sensor networks. I did a project with you that was actually independent of my advisor on CTP, right? And that was started by 4 PhD students and one research, 3 PhD students in different schools and one professor that had nothing to do with their advisors' projects. And perhaps I think the most interesting project starting that I had was this project called Quanto that I did with my colleague Prabal Dura, who's now a professor at Michigan. And I had done a project before on tracing the execution of distributed systems called Xtrace. And so I was thinking a lot about how to relate events happening concurrently across nodes of a distributed system. And I was hanging out at the lab where people were doing the actual sensor network research. I had stopped doing that for a bit. And they were discussing, we know how to measure the power that different components of a platform, of a sensor network node are using. But there's a problem with asynchrony here, because, for example, when the radio is using energy, it's not using energy on behalf of the thing that's currently running on the CPU. So we need a way to correlate these two things. And I was there listening to this, and I said, well, I have a way to do that. I can apply some of the concepts that I was using for my other work in distributed systems to this problem. So we started working on this, and it culminated with a system called Quanto that allows you to track the energy used on a sensor network node in very fine-grained way. So it tells you which component of how much energy each component of the node is using on behalf of which programmer-defined activities, which is the equivalent of processes, if you will. And it's also interesting because it can tell you, node A is using so much energy in its processor on behalf of a packet that originated in node B. So we could have actually network-wide asynchronous energy usage correlation. So the other interesting thing about this project, which is in stark contrast with the first project that I did, which was selected or suggested by my advisor, was this project was, I was about to finish my PhD, and one of my co-advisors explicitly told me, hey, you have to finish. Do not work on that project, on this Quanto project, which I did anyway. And it turned out to be one of my favorite projects. So this can be viewed as an indication that you're getting ready to graduate when you start to we start to have more confidence on your selection of problems and projects that you start to even question your advisor.
Now, you are a faculty at Brown University. How do your students find research projects? And do you force them to work on your ideas?
Seriously, it's not exactly the opposite, but definitely not that. So what I do is um, I have a few topics that I'm interested in generally, and in talking to the students, I generally describe, like to a new student, I describe the projects that I have going on. But I always encourage them to at least select which topics of the ones I told them interest them most, and I'm not opposed to their coming up with their own ideas. And if it's, as long as it's something that I can help them with, and I think that's a fine thing. Of course, I'll exercise my judgment to say, well, I don't think this is a good idea because of this and this and that, but we could explore this other topic. So one of my currently most successful projects is called participatory networking with one of my PhD students, Andrew Ferguson. The kernel idea of that project, which is to allow applications and users to inform the network of their needs, such that a network can configure itself to maybe perform better according to what the applications are telling them. This idea it started with an idea that Andrew had about a conversation between applications and the network, which is very different from the ways networks are configured today. So it's pretty much the kernel of the idea is something that he was very passionate about. I was not really working on anything directly related to that, but we started, and it's been very successful. One thing that my advisor told me, a question that he posed to me one time when in one of the many times in which I was struggling on which topics to work on, he was like, you should work on a topic that potentially will keep you awake at night thinking about solutions and problems. So you should be really passionate about so he would ask, what keeps you awake at night? And that's, if you have a topic that does that, then go for it.
Okay, so let's assume that we found a research topic that's going to keep us awake at night.
Okay.
Next, I want to understand what happens during these nights, or what happens between the start of a project and the time a paper is published.
I think the most interesting thing that happens is that usually the exact idea that you start with, will be changed significantly when you actually finish the project, because it's a research project, so you don't know all the answers, you don't know all the path as you start, right? You start with a general question, and as you get more results, and as you start developing some hypotheses, some small ones, and you start to try to do experiments to validate them or fail them, and each one of these little results that you have, they produce forks in the road, and in the end, you don't know exactly where it's going to lead you. I think some projects start with a high-level question that in the end gets answered, but some projects significantly change. So, for example, this project that I mentioned called X-Trace, which ended up being the topic of my PhD, started with a question that was like, wouldn't it be nice if on a network we could understand we could have information that layers can pass to each other. So, the application layer can inform the TCP layer, which can inform the IP layer, which can inform, some of the routers along the way about some context in the application that gets propagated throughout the layers. And we were thinking of something that would be something like an annotation service that works across layers. As we started working on this, it became, instead of this annotation service, it became a way to record steps of the execution of a distributed system, including concurrency and including abstractions that can be used to troubleshoot large-scale systems. So not exactly what we set out to do, but very related. And on this project that we had together, for example, CTP, which is a routing protocol, I think we may not have started with a big question, or like, well, we want to solve this problem, but something like, we have some experience in implementing ad hoc ways to collect data on a sensor network. We should build a protocol that crystallizes all the things that we've learned. And as we started to build this, we saw that it was extremely hard to get this right, to get it reliable and so forth. And a lot of research questions appeared because of the problems we found when implementing them, so after the fact. Another thing that I could say is that when you look at a paper, you see some nice graphs, right? You see some data that gets presented in that paper. And this may be obvious to someone who has done this before, but when I was starting out, I remember thinking, oh wow, so I have to produce these graphs and this would be the paper. But in fact, when you're really exploring a space, for example, a parameter space for experiments or a parameter space for simulations, you have to go through a lot of data, through a lot of experiments, either or a lot of simulations, and produce a lot more data, like orders of magnitude more data than it will ever show up in the paper. So the more data you produce, the more data that you can analyze it scalably, the better the way you can synthesize it. It's also related to the thing that you should be able to fail fast whenever you're exploring a new idea, right? This is related to the small hypotheses that I mentioned that you have to go proving along the way. You should really think about a question and have a way to test that question quickly. And the quicker you can go through these questions, I think the further you can get.
Do you have some examples you want to show?
Yeah, I do. So one thing that I did is I worked with Mike Friedman, who was working on this system called a Coral content distribution network. And we instrumented Coral with Xtrace, and I started collecting execution graphs, which is, you can think of them as call graphs. So you have events that call other events for 1% of Coral's web traffic, and it was getting a lot of traffic. So then the question was, okay, so what do we do with these graphs? And I had to find, I was trying to find interesting or anomalous behavior in Coral, or maybe trying to troubleshoot or debug Coral. And as you can expect, I collected, hundreds of thousands, millions of graphs, and then I had to look through them. And one thing that we did for this was to create an interactive system to look at lots of graphs and be able to refer to them. And also, so we associated that with the wiki. So this is an example that I had from the Coral instrumentation. I have the size of an object on the x-axis, and I have the processing time for Coral, so how long it took to serve that object. And the important thing here is that for every object size, for example, 10,000 bytes, there's at least 5 orders of magnitude difference in the amount of time that it takes to serve that object. And for any processing time, there's also 5 orders of magnitude at least in terms of objects of some size that took that time. So of course, if you're a web operator, you would be really puzzled to see this graph. How do you even start to understand what's going on, right? So we instrumented this with Xtrace, and then I looked. I had a way to look at the graph corresponding to each one of these points. So I selected this sliver here, for example, that had a bunch of tasks that took approximately 189 seconds to complete. And the color just represents the HTTP status. But then I looked at the Xtrace graphs for each one of these. And again, don't bother trying to read anything. But some of them had this amount of time because it turns out that this is a Linux TCP timeout if the if the other side is not replying to your SYN packets. Or sometimes it was just the fact that the connection between the proxy and the client was very slow. Sometimes it was because the connection between the origin and the proxy was very slow. And sometimes this was running on Planet Lab, and it just happened that the slice in which this was running got descheduled, and there was a timeout in the execution of the code itself. So the very different X-trace graphs for each one of these things. So another thing that we did, and this was between myself, my advisor, and Mike Friedman, and George Porter, who was also working on this, is that we created a web interface in which we could visualize all these different traces that were produced in a somewhat interactive fashion. And there was a specific URL for each one. And so this is one example of that interface. Very simple, but it just has here the ID of the execution on the left side, some metadata about it. Then you could click on the graph and actually see all the nodes in the execution, and you could explore, for example, this is an agent invoking a command line of this class at this time, and so forth. Again, detail is not important, just that you can explore the graph and understand a little bit of its structure. So going back here, on this wiki that we collaborated with, I had, for example, this is a list of bugs that we found, and this is one type of bug, and this is an example of a task that exhibit that bug. So you could go here and look at the graph. So this allowed us to document what was going on and also go through a very large number of graphs in a collaborative way and quickly. This is something that I've used in many, many, many projects, is to have an automated way to generate multiple graphs and then display them side by side. This could be, I've done, experiments controlled by shell scripts that would generate lots of graphs generated by GNU-plot with a Perl script that would combine them into a PDF like LaTeX document. I've had matplotlib scripts that generate web pages, and in this case here I'm showing just one example, a page of a wiki of a project, and we were trying to understand a hypothesis that we could use convolution to test some correlation among different events, and we just generated lots and lots of graphs with varying parameters, and we could see them all side by side and understand when or not there was a correlation or there was a shift. So this is just something that I would always suggest. Automate your plotting abilities and find a way to generate all the plots and put them in a document, either a web page or a PDF that you can share and can look and quickly glance at a lot of things. So this is what I wanted to share in this regard, just this ability to automate and don't be afraid to generate lots of data, lots of graphs, bearing in mind that whatever goes to the paper is just the very tip of a very large iceberg.
That's a great tip. Related to this theme, I wanted to ask you, what has really worked for you as a text editor or a note-taking system you would like to share with us?
Everyone has their own favorite text editor. I've been using VI and Vim forever, but I'm not the most hardcore user of Vim. I know people who have transformed Vim into full-fledged IDEs with the right plugins. Some people like to, Sublime text seems to be a really popular one these days. But there's one thing that I've been using for taking notes. I've had several forms of wikis in the past. I think they're great for collaboration. But personally, I've been using this little wiki that's portable just for myself called Tiddly Wiki. Okay, so this is just one example of this Tiddly Wiki that I set up, and I use it to write notes. It's a JavaScript-based single-file wiki, that I store on Dropbox, and you can access it from the browser. And it has, on the right here, all the notes that you have ordered by the date in which you last edited them, and they open and close like that. And you can have several of them open, and you can edit them. You can also add tags to them such that you can search them by tag, by date, or by just keywords. Yeah, so in terms of tools, the other things that I like to use, you definitely need a good bibliographic manager. On the Mac, I would recommend BibDesk. And you should also, definitely learn a good graphing tool well so that you can produce expressive and good graphs. I like Gnuplot a lot. I like the quality of the graph that R produces. And for quick exploration, you can even use Excel, or I've been using Matplotlib as well, just for quick stuff, although I don't think their graph quality is up there with R or Gnuplot yet. No.
Okay, great. So today we learned about the path you took in how you found your first and the subsequent research topics. Hopefully we can use that as an example to consider, at least, if not follow the same path. And we also got a lot of very useful tips on plotting and editing text and taking notes as well. We thank you for your time today.
Thank you.